How can one draw an enantiomer, if that's how it's pronounced? It's actually a lot more simpler than you would expect. So I did explain earlier that when we have a chiral center, that means that there can be a stereoisomer, right? So that there's a chiral center in a molecule. Let's make a really simple one. Let's take a look at this molecule right here. Now, there are two substituents here which are exactly the same. So let's quickly change that. And now there's two hydrogens here. You can see them pointing out, right? So we'll change that too. What we're going to do is put something else here. Now there's a fluorine. So there's a fluorine, there's a methyl group, and there's an oxygen group. And then right down here, there is a hydrogen, which you cannot see. This is the chiral molecule. Why? Because there are 4 different substituent groups. Okay, so that's all great. But if it's chiral, what that means is that there is a mirror image of this molecule that can be drawn. And that mirror image would be the enantiomer of this compound. And there are always going to be 2 enantiomers for every chiral center that exists. This is one of them. Now we're going to draw the other enantiomer. The process for doing this is actually a lot easier than you would expect. There are more than one method to doing this, but the most easiest by far is the mirror example. Now imagine I drew a huge line here. Forget the carbons. Pretend I'm just actually drawing a line. Now imagine that there was a big long line between these two. And this is a mirror. And on the other side, I'm going to do the exact reflection of what this is. So we're going to make that real quick. So what I'm going to do is I'll move these things. I'll drag them over here. Good. And then what I'm going to do is I'm going to make its reflection. In fact, you know what? This might make this a little faster. There. Now what's wrong here? Imagine this is a mirror separating the two. This molecule is looking at itself here. What should be on the other side should not be this. Why? Because this is the exact same molecule. It's not a reflection of that compound. So we want a reflection. So what we would have to do is flip it. So we're going to completely flip it. So we're going to put this OH over here, and we're going to put that methyl group over here. Now what about the fluorine? The fluorine can stay there because no matter how much you rotate this area right here where there's the methyl and the oxygen and the hydrogen, this top up here, it stays like a standing pole that just continues to be in the same spot as the rest of the body rotates. So for this compound specifically, we're good. This is fine. This is the enantiomer of this compound. Okay, so what if I have a more complicated molecule? It's the same principle. So let's try something like this. We're going to use benzene, and then I'm going to put one group here, one group here, and I'll put an oxygen here. Okay. Now what do I do if I want to make the enantiomer of this compound right here? Again, very simple. And you're going to literally do this as you draw it on paper. You're going to have the same backbone of the structure that doesn't require it to be flipped. But everything else that is not a reflection must be flipped. These double bonds here are not reflective to this structure right here. So we're going to flip them. So we'll remove this double bond here. make this a single bond, and we're going to put a double bond. Well, actually, you know what? Let's remove all these double bonds. Perfect. So where are we going to place these double bonds now? Should I place one of them over here? Well, that would be correct, because if this small compound looks at itself in the mirror, what it's going to get back on the other side is this being here. And this, it's going to get it over here. And for this double bond, it would be here. Now this is partially a reflection. What about these two substituents here? Well, they can't be on this side actually. Instead, we're going to have this come here. Oops. So I'm going to have this methyl group here. Oh, that looks pretty messy. So for all intents and purposes, or you know what, I don't want it to be messy for you, so there we go. And there's going to be one methyl right here. Okay? This, we're going to get rid of. And we're going to get rid of this. And you know what? We can get rid of this whole mirror thing, because we know what's between the two now. Now what we're just going to do is we're going to add the OH. There. This is the same compound, but reflected. Is it the same structurally? Not quite so, but it is the enantiomer of this one. And we know that these two enantiomers exist for this compound because of the chiral center that exists within the compound. And there can be more than one. So that's pretty much how you draw enantiomers in a nutshell.